Hello. Someone else had a video on a kegerator, which was basically a chest freezer that they extended the top on so it would hold a keg, and people could have beer parties at their camp that was off-grid. Now I live off-grid 5 months a year, and I have a chest freezer, and mine operates under control. Basically the whole house operates on this. With my small amount of solar panels, I have hot water, even a dishwasher. I'm not lacking for anything, and yet I only operate with a car battery. So one of the main questions that was asked about this kegerator project was, why is it so expensive? And it was. You had to have a massive amount of batteries, solar panels, just way over the top expensive. And I thought I'd come up with this that someone could build. I prefer doing it in a microprocessor, but other people would rather deal with a zombie apocalypse than do any programming. So here's what you would normally buy is a temperature control board. These are they're in the $2 range shipped. I mean, it's hard to believe they can even make them. Comes with a temperature sensor that you can put in. This added stuff uses two LM431s and a PNP transistor, and the whole setup costs less than $5 to build. And if you have a couple old wall warts, these LM431s are often found in those, and you can steal them. But even buying them will only cost you a couple bucks. And the relay I pulled off of something. So what we do is it has a voltage sensing pot that we adjust. And in my system, because I told you I only have one car battery that powers the whole house, the battery is just used for starting currents, and the rest of the time the power is provided by solar. I mean, if you can get 6 or 7 amps out of your solar panels during the day, that's enough to run the refrigerator. The refrigerator is about 9 amps, and so you could pull a little bit off the battery, but you're never really bringing the battery down very far. This one, we're at 12.5 volts. We're going to run it up to 13.9, and now you see that it's turned on and the controller has turned on. Now the nice thing about this is when you actually have the thing powered but not on, this whole system draws less than 1 milliamp. And so running it overnight is not going to drain your battery. It's very energy efficient. Now this temperature controller has a 10-minute time delay. I've set it to 1 minute, and you'll see the little LED come on shortly, and it has a set of dry contacts from this relay. That is what would turn your inverter on. Your inverter doesn't even need to be on too, so you're not drawing any current until you're actually doing some refrigeration. I have a little button over on the side, so anytime you wanted to see what the temperature of the refrigerator is, you could just press that, and as long as you press it for no longer than what the time delay is, the refrigerator will not turn on. As you can see, the LED came on, the refrigerator would be cooling, and now what we would do is the battery voltage would drop after a while, and you get down to 12.5 volts, and it's turned off. So you're back to drawing just about 1 milliamp of current. The system's off. It'll wait till it's 13.9 volts again. That's adjustable, but you can buy some of these controllers on eBay, but the turn on and turn off is so close together that if you use them, it's guaranteed you will destroy your battery. Getting it up to at least 13.9 volts and having a sufficient number of solar panels that it occasionally gets up into the mid-14s, your battery will be fine. It'll never be fully discharged. It'll be great. But if you keep dropping the battery down to low volts and don't let it get up to what a normal full charge would be, the battery will be destroyed. So that's the reason I have this 13.9 volts, and this is my controller is adjustable from the pot, from turn on at 13.2 to 14.5. Mid position is about 13.8. And again, here's the current, 1 milliamp when the thing's just sitting there at idle. When the LED turns on, you're drawing about 40 milliamps. That's the relay and what the board draws. The board draws about 15 milliamps. And when this relay comes on, it's another, 40 milliamps. So you're drawing about 100 milliamps while the refrigerator is on. So it's very low current. You got to have the time delay. It's a must. That's setting P5 on the controller. This board, if you look it up on eBay, is a W1209. And if you get one, check to see if it remembers. If it doesn't, complain. The cutout I have set, it's fixed at 12.5 volts. So you set the controller, it's in centigrade. Hey, blame Jimmy Carter that you don't know that what centigrade is. But setting it to 0.5 to 2 degrees centigrade is good. You want to have a 1 to 2 degree hysteresis. Maybe you can go a little bit higher depending on if you're doing food or just drinks. Set the thing in C for cooling, and there you are. There's your kegerator control. Hope you enjoyed this. If there's any interest in this, I'll do a part 2 with the part list and schematic and how to build. Thanks for watching.